Hi, everyone, and welcome to the first ThreatX webinar here on Bright Talk. This one is going to be about the evolving cyber threat landscape, defending against complex mixed mode threats. I'm Diana Kelley, CTO and founding partner at Security Curve, and today I'm joined by Tom Hickman, Chief Product Officer at ThreatX. Welcome, Tom.
Hi, Diana. Great to be here.
It's so great to have you here. I'm really looking forward to the discussion. And we're going to be together uncovering the evolving cyber threat landscape and helping you to understand how to defend against these complex mixed mode threats. I got to be careful when I say that because that is a bit of a tongue twister.
It's a mouthful for sure. Yeah.
Thank you so much for being with us today.
Great.
So, Tom, in recent years, the threat landscape has undergone a transformation. When you look at the sophistication, the diversity, the volume of attacks, I mean, even after, when COVID hit, we saw so much human-operated ransomware just light up because the attackers had been dwelling in organizations waiting to strike at the most opportune time. Can you explain a little bit about what's going on here?
Sure. So there's kind of, from our perspective as defenders, and really as longtime security practitioners, there's a convergence of things that are making for kind of a perfect storm in the threat landscape. Bitcoin and the ubiquity of sort of non-traceable transactions has allowed a lot of money to move in the dark web and in the sort of underground economy without the kind of traceability that it had when you had to actually move real currency around. So there's one point that's just kind of enabling the business model of ransomware as a service. There was the T-Mobile breach from late summer was brazen in the sort of advertised 250 million in Bitcoin price tag for the data that was exfiltrated in that ransomware attack, right? Like, it's just a business model now, right? So there's item number one. The attack surface area for every enterprise is expanded. So item number two is, we run the world's economy on web apps and on internet applications, on internet enabled applications. So the attack surface is huge. The attack surface is itself multifaceted with multiple tech stacks, multiple cloud platforms, multiple third party, second party, first party APIs. And that world makes defense really difficult, right? So security practitioners, CISOs, and operational security teams have an ever expanding landscape to have to cover. So that's item number two. We all know the DevOps transformation that started a decade ago, moving, lift and shift, get stuff out of your own data center, get it into a cloud provider data center. The reason that was so successful is there's economies of scale for operators, right? Like, it's much cheaper to let Amazon rack and stack your hardware, even this week. And right,
not
with
the
Amazon outage yesterday.
Yeah.
It's cheaper for Amazon to do that at scale, which drives down the cost of computing for enterprises, which creates this impetus to move to new technology stacks, new virtualization platforms, configuration as code. And we all know that it's now trite, the phrase moving at the speed of DevOps. Well, that's a real thing, right? Enterprises are building faster, they're deploying faster, they're deploying more, they're scaling faster, and they're doing it all in kind of like automated infrastructure as code environments. And that pattern you can think of as kind of being phase shifted from what we've seen in the attacker world and in the attacker landscape. So just as my team now deploys code, easily, configuration as code, we do a check-in, we do a push, we type some things, and suddenly there's instances, and those instances have our source code compiled and running, and it's just, compared to the old days, auto magical. Well, the bad guys have the same technology, right? So they're doing the same thing, right? Which is why there is now a phrase, ransomware as a service, right? So bad actors are building solutions the same way that we build defense solutions, and they're using this infrastructure to attack legitimate businesses. So big convergence of at least three major movements there.
Yeah, we used to talk about, back in the day about we call it the Cold War, remember, because it was like we get additional defenses, and then of course they were also had additional offenses. So
right. We think of it, internally, our company was founded by security practitioners about 7 years ago, and the CTO and co-founder is a lifelong pen tester, and he thinks about it and talks about it as a cat and mouse game, right? And it really is that, right? It's the attackers are smart, right? Brilliant geniuses who have just chosen a life of cybercrime instead of a legitimate enterprise. So they're always trying to get one up on the defenders, and then when the defenders get a new technique, a new strategy, a new tool, a new platform, a new partner, maybe the defenders get a little bit of a head start or a little bit ahead for a quarter, 2 quarters, a year, 2 years, but the attackers are always evolving. So this cat and mouse game is a real thing, and it's the same as Cold War escalation, right? So.
Yeah, and as you pointed out with the ransomware as a service, there can be attackers or cyber criminals who figure out flaws or exploits, and then they can sell it to others and continue that business model. They don't even have to be doing the active crime themselves. They can sell their knowledge.
That's a real pattern. Unfortunately, that's a real business. There's state actors that are in the same business, or at least sponsoring the same business. And what that means is for every enterprise, you have to stay vigilant on known vulnerabilities, and you have to have defenses against unknown vulnerabilities. That means security in depth for sure. There is no more single, one size fits all security posture. It means application security. It means perimeter security. It means operational security. It means, partnerships with MSSPs. It means 24/7 vigilance across your entire tech stack to stay ahead, both of the known vulnerabilities with published exploits, as if that weren't bad enough, but also of new zero days that have been discovered by, hyper sophisticated researchers.
Yep. And as we look at that, this hyper sophistication in the attack methodology, what happens to traditional tooling? You were talking about the need for layered defense. I mean, where are we? Will old tools protect us against these new attacks, or do we need to layer new tools on? In other words, and I get this question all the time, I'm sure you do too. If I have great EDR, endpoint detection and response, can I get rid of my network or my cloud-based firewalls? So how does this shift?
Yeah, we don't think so. We don't think that there's any sort of evolutionary tool that is going to be a one size fits all. What we see, in fact, is kind of a necessity to look not at single points in the kill chain, single points in the perimeter, but to look holistically, because attackers are basically mining for weak points. Mm-hmm. And attackers understand the defense mechanisms that are in place. They know, basically where the tripwires are. They know, what the level of recon and probing they can do without hitting a tripwire, without getting blocked, et cetera. And what that means is in our experience, prospects, enterprises that we're not doing business with today, come to us because they're not getting breached, but attacks are getting through to their origin servers, through to their assets, and they're getting through traditional web app firewalls. They're getting through traditional perimeter security, because that perimeter security is looking at one facet of an attack, one piece of signal, one indicator of compromise. And what's in fact happening is the attackers, because again, they're leveraging this convergence of tech, they're building attack platforms themselves, and they're sophisticated enough to know that they can, kind of go up and rattle a doorknob and see if that door's locked, and then stop. Maybe the door opened. If so, they take a note and they're like, yeah, this door seems to be open at 3 o'clock on Tuesdays, right? They don't come back for several Tuesdays, right? So they're trying to avoid detection. They're trying to build a map. They're trying to recon, understand the attack surface. And then when they get a significant map, maybe then they'll they'll start a brute force or a DDoS attack. Maybe then they'll start spraying account credentials at an endpoint, but they'll have done so in a way that lets them see, all right, I can do 2 login attempts at this endpoint a second. I can do 3 in a row, and then I have to cycle IP addresses, or then I have to cycle user agents. So it's less of a brute force denial of service like we've seen in the past, where they're, somebody's just being malicious and trying to take a service down. It's more that they're staying just below where defense mechanisms will kick in. And what that says is that you need a risk engine that's looking across multiple facets of attack, looking not just at the sort of visible and obvious, but catching that there is, malicious intent coming from this entity, which is a botnet, which is using 45,000 IP addresses and cycling user agents. And that's the multifaceted part of what we're seeing in the evolution of attacks.
Yeah, they've become just so multi-channel. And you mentioned a really interesting point about how they're able to hide themselves, how attackers get into networks and create these low and slow attacks that they stay below that threshold of detection. I was wondering if you talk a little bit more, just so people understand the kinds of techniques that they use to stay below the radar.
Yeah, the metaphor that we use, and this is a slippery one to explain to people, both practitioners and non-practitioners. Traditionally, attacks were, relatively obvious, right? There's been the OWASP top 10 designation for attack types. It's a nice taxonomy that kind of lets people get their head around what bad guys try to do to web servers and APIs. Those attacks are honestly, relatively easy to detect. They can be detected with static or semi-dynamic signatures, and you can say, all right, well, this is an injection attack. It's clearly trying to pass executable SQL code to, some endpoint or some web app that's going to, maybe pick that code up and do something that, unintended, or at least unintended by the developer who wrote the code, certainly intended by the attacker. That's the tip of the iceberg. That's the stuff that you can see, right? What's happening, below the surface is, things like a legitimate login attempt, right? That looks just like a real user. This could be grandma trying to log into her bank account, right? Mm-hmm. Except it's not. It's a scripted attack. And it's not grandma, it's maybe grandma's credentials, but it was credentials that were exfiltrated and sold from some breach that you read about 18 months ago, right? So those credentials exist. They're out there in the world. There's a username password pair that was exfiltrated. And, there's also like dictionaries of known passwords, easy to guess passwords. People are really still very bad at this part of cybersecurity. But they'll try, every combination of grandma's username and a likely password. And then they'll do that very slowly, right? Over days or weeks or even months, we've seen. And that stays below the threshold of detection, right? So that's below the waterline. And instead of, maybe they actually finally get access to an account. Instead of immediately exploiting it, they'll just say, all right, well, I've got access to an account, and they'll stop, right? So they won't draw any attention to themselves. At that point, they've basically done, for all practical purposes, a successful account takeover attack in ATO. And they'll sit there. They'll live off the land. They'll see what other information they can get. They'll see, what other kind of a dossier they can build. And they'll use that information to go, kind of around to other sites that they can attack. So it's all kind of information gathering below the waterline. The other thing we see is, obviously, with that easy to turn on and easy to procure infrastructure for attacks, you can cycle through IP addresses. So if you block one IP address, they'll just go to the next IP address in a range. They'll cycle through user agents. So, the first request will look like it's coming from Chrome. The second request will look like it's coming from Safari. And that makes a lot of defenses think, oh, this is legit traffic, right? So attackers are essentially hiding in legit traffic and staying below the threshold that, a bot mitigation solution might say, well, this looks like a human, right? So that they'll have some attack patterns that get through that, that particular attack. And it's only by looking at those all together and aggregating the entities in our parlance and looking at behavior over time that we can see, oh, you know what? That entity did something sketchy a couple days ago, right? It wasn't blockable. It wasn't like clearly malicious, but that entity probed a couple of directories that don't actually exist. And that looks a lot like maybe it was recon, right?
Yeah.
And then, entity goes quiet for a while. Well, we don't forget that entity probed a couple of directories that don't exist. A week later, they come in and they drop a username password pair on an endpoint. Maybe it looks normal, but we also know that maybe they didn't do a get to load what would be like the login page before the client sent that dyad of username and password. So again, an indicator that's like, that's sketchy. That's a scripted, attack. Maybe it's a client. Maybe grandma got sophisticated and wrote herself a little script that logs into her bank account, but probably not.
Right.
And so
depends on the grandma.
Exactly, cyber grandma. I love it. So by virtue of sort of aggregating and looking at that sketchy behavior over time, we see the whole mass of the attack, and that's the iceberg that's under the waterline.
Yeah.
Right? And it's not the bit that you see poking up above the water that's going to get you. So.
That's right. It was the base of the iceberg that got the Titanic. And they're using automation. You also use this term that if folks haven't heard it before, I think it might be helpful for you to expand on it, which is living off the land. And what does that mean when an attacker's in your system? How does living off the land enable them to evade that detection point?
Well, if they're, so the worst case scenario is that they're on a host, right? That they've gotten, some credential that's let them get a shell access in a container or workload or a server. And if they're smart, they won't do anything with it right away, right? They'll sit there. They'll map the network. They'll very quietly probe for vulnerabilities, and they'll be kind of in the soft, gooey center of your data center instead of outside in the big eye internet. So they'll be, now able to look at traffic, surveil, service to service calls, look at patch levels, look at operating system levels, and all that time they're building a map, right? They're building, essentially a big diagram of what your network looks like, always probing for vulnerabilities. And, they'll dwell there for days, weeks, or months, probably years, until they have an opportunity to strike. And by strike, it's usually these days, encrypting data in a ransomware attack, or just straight up exfiltrating data to sell usernames, passwords, credit card numbers, other identity information on the dark webs.
Yeah.
It's a real business. Like you said, it's a Cold War for sure.
It is. It's definitely a real business. When I was at IBM security, one of the gangs that we were criminal gangs that we were watching, went dormant in August, and it really appeared that they were taking a vacation because they came back up in September, and we're like, wow.
No doubt,
if you ever wanted to know, it's a business.
Yep.
Vacationing.
You have to, I guess you have to take care of your employees, whether you're in a legitimate business or a nefarious one. So
yeah. So I was wondering if we could shift a little and focus specifically on APIs.
Yeah.
First of all, would you mind explaining why they are so important to modern development shops?
Sure. So an API, so this is a fun one to explain. For anyone who's done any amount of programming, you'll remember, like, in these super old days, there were like a go-to call. So you would be programming in BASIC, you'd go along, everything would execute linearly, and you'd hit a section of code, and it would say to go to line 100. And in line 100, there would be a piece of code that would say, oh, somebody has called me and they've given me a number. Well, I'm going to do an operation on that number, and I'm going to pass it back to the line of code that called me. Right. So that's kind of a function or a procedure It's a small unit of computational operation that a program does. And that's really all the magic is of coding, right? It's just having, giving something a number and letting it do something to that number, right? If you think of APIs, what APIs do is take that same basic operation of, I want to do some math to something. And it's all math because it's all binary. And I'm going to expose that now to the big I internet. And there's a whole lot of technology between the client operation that's going to say, hey, I've got the number 4. I would like you to add 2 to it and give me back whatever that sum is. There's a whole lot of operations that happen in between. There's a transport layer, there's TCP IP, there's HTTP, there's network infrastructure, there's cloud infrastructure, but eventually somebody way over here says, hey, here's a number 4. And then somebody way over here says, okay, great, I got your number 4, I'm adding 2 to it, here's a number 6. So that basic functionality of, somebody calling in and asking for some computation to be done, and then a computation happening and the answer being given over the wire, is for lay people kind of like the best I've been able to do to explain what an API is and what an API call does. So the API call says, hey, here's a 4. And then the return says, okay, cool, here's a 6. It's 4 plus 2. That's very hand wavy, but what's happened in open source development and general software development methodologies and evolution is that all of that infrastructure that can carry that distribution network for computation is now at the level of third-party libraries that you just get and build into your solution. Yeah. And then your APIs become the building blocks of your web application, your website, your banking site, your e-commerce, whatever it is, your medical records management site. So the API patterns are, known and taught in computer science classes and learned by developers, beloved by developers, because it gives them a lot of power to do a lot of software development very quickly. So APIs, with all of that drag along infrastructure, are the building blocks of modern applications. So what does that mean? It means that clients, instead of hitting a website and having all of the business logic contained in the website, clients have some of the business logic, and that client could be an app on your phone. They have some of the business logic there, and then they're making these calls. The calls are going back to computers. The computers are doing small quanta of work. The computers may be talking to other computers via API calls to pass off authentication requests, to pass off like commit to disk, database transformations, whatever it is. So API calls are kind of now underlying all of the complex computational stuff that we take for granted every day. Because it's complex, it's vulnerable, right? An API call at the end of the day is taking a command and it's letting the computer execute that command. And we talked a couple of minutes ago about SQL injections, right? Injection attacks. One command you can give a computer is, hey, look up the data, look up all of the usernames and passwords in the database and give me that, please. Well, if the application wasn't well constructed or well defended, that SQL injection attack could immediately exfiltrate a bunch of data, unintended, but the API would be the mechanism by which the nefarious command got to the server. And again, if not well constructed and well defended, that server could execute malicious code, which kind of underscores the really call to action to have well defended APIs and API infrastructure.
Absolutely. And that's one of that was just such a great explanation of the importance of APIs. I don't think I've ever heard it as quite as clearly expressed. Thank you. So, as you ended, you said this is why we have to protect them. And if you look at the OWASP top 10 for 2021, they just put out the revision and injection attacks, as you mentioned. They're up at 3 right now.
Yeah.
How do we protect APIs? What's some of the best guidance or good practices?
Sure. So security in depth, I will say forever, right? And I was very careful in saying well-constructed and well-defended. On the well-constructed side, you know, every shop that's building software today should have, you know, a highly scrutinized, routinized, and well-managed application security program. And that means teaching your developers defensive coding methodologies. It means testing your software in dev, in QA, before it goes to prod. It means having vulnerability scanning solutions. It means having software, you know, basically binary analysis or static analysis solutions in place. It means annual or semi-annual penetration testing to have like people with an attacker mindset telling you what the vulnerabilities are in your software. So all of that stuff is table stakes. And then well defended is also critical. And then well defended, you know, we have a dog in that fight, right? We think that our architecture is the best architecture for defense of APIs. We take a protection first approach. So anything that is using HTTP or HTTPS as its transport mechanism, which is, you know, most of the design patterns that I mentioned before, are subject to that iceberg of risk underneath the obvious attack patterns. And that's one where, you know, we think attacker-centric behavioral risk analysis is really key to good defense. And then the last bit I do think is critical. The API design pattern, the ease of use, open source software, you know, the simplicity of discovering solutions, you know, in the wild, you know, in the open source community, and building software without being a software shop per se, means that a lot of organizations are building and deploying first party. They own them, they wrote them, APIs that, you know, they're not traditional software companies. It's not IBM, it's not HP. I use the example because I'm from the South. I think Billy Bob's corrugated sheet metal and financial services, right? And, you know, my buddy Billy Bob from Jonesville, South Carolina, where I grew up, you know, he hired a couple of developers and he put up a website, and that website's exposing APIs, and he's got his customer data in there, right? Well, Billy Bob's not an AppSec professional, right? He's a good guy and he's running a tidy little family business, but he is not a security practitioner. Sure. He's not a security professional. So in that realm, I think partnering with organizations on the defense side that offer a managed service solution, an MSSP, is critical, because, you know, we all know, we face this every day. There's 300,000 fewer security practitioners on the planet than there are jobs for them today, meaning we are in a labor shortage in this industry like crazy. And organizations that don't do security for a living can't always attract and retain the right talent. They can't build their careers. They're, you know, we've seen, you know, customers lament over and over that they'll hire people into their security operations. They'll train them for 18 months and then they'll leave and take a job at, you know, IBM security or ThreatX for that matter. And, you know, companies like us, I think, do a good job of, you know, kind of building that team, retaining that team, growing it over time. And that's when we're, you know, we like to say we're on the wall with you for our customers. Mm-hmm. And I think having a partner on the wall whose job is defense, who lives and breathes security all day, every day is important.
Yeah, absolutely. Billy Bob's store with what was it, financial services and corrugated metal, reminds me of, there used to be a store in Western Massachusetts that was Soda and Pet Food City. And I thought,
oh, funny, Soda. And I never saw Soda and Pet Food City. So.
Yeah. You never know what people are going to do when they go into business. I guess at least it was two kind of foodstuffs there.
Yeah.
So you see, I'm sure you see a lot, Tom, in your role about what customers are dealing with and how attackers are really, you know, on the ground exploiting these attack kind of patterns. I was wondering if you could share, obviously anonymized, but share some real world examples of what you've been seeing.
Yeah, one of the interesting things, and this is an example of these multifaceted shifting attacks, right? That are staying below the threshold of other detection methodologies. And I'll anonymize both the customer and the incumbent in these cases.
Yeah.
The industry was financial services, and specifically the credit union industry. And credit unions in America are about where private banking was, in the 2000 to 2005, right? Credit unions are you might hear credit unions and think, oh, tiny little regional. Well, they're big operators and they manage a lot of assets.
Yeah.
And a lot of private banking has moved into that realm. And credit unions are kind of organized and affiliated. A lot of them use very similar tech stacks, a lot of the same vendors. Yeah. And they are convivial with one another rather than like hyper competitive. So a lot of the security practitioners in the space share notes, right? They talk to each other. We were lucky enough to win the business of a credit union in early 2021 in what we call a hot POC, proof of concept. They came in, they called us, they were under attack. Their existing solutions weren't blocking, weren't scaling, weren't able to keep up. They were in the classic WAF kind of failure mode of having to, not having enough staff to keep up making static signatures to block all of the attacks that they were able to see. And they were doing that as forensics after the fact. Now, they weren't explicitly breached, but the attack traffic was getting through to their origins. And so they came in as a hot POC, came into our environment, set up, did the necessary to kind of let us proxy traffic. And, we immediately started aggregating risk on these entities, figuring them out, and we're like block, automatically, right? So our risk-based blocking turned on and they were in good shape. So yay, they're happy. Their origin servers are no longer getting slammed and attacked. And weeks later, same attack has moved over to Credit Union X, all right, the next one. Their incumbent was also failing. They call around, they're like, hey guys, are you seeing this? And we're like, yeah, we saw that last week. You guys should call ThreatX. And it was exactly that pattern of kind of articulating, tracking the low and slow risk. And then when it hits, full bore, being there and having, the entities already created so that when they actually go malicious or go, out into the open in their attack patterns, we've already built the profile and we're already blocking them, right? So that real world example has repeated itself multiple times for us, and really is, I think, one of for me, it was one of the first indicators of just exactly how big that iceberg was below the surface.
That sounds like a really powerful way to leverage security economies of scale. That's one nice thing about the cloud has given us, even, is that, we see an attack in one place, we can now, the security providers can now protect against that, as opposed to when we were all having to write these very arduous, difficult rules on our own.
Yeah,
there
is for sure, a network effect in this, right? That, and again, I think this is why, we encourage people to partner, right? I mean, obviously we exist to be a partner for our customers, but we encourage the partnership because the go it alone approach, it sort of says you're not benefiting from indicators of compromise that could be coming from other clients, from other industries, from other segments of the economy. So at the end of the day, back to the Cold War metaphor, we're all in this together, right?
So what do you think the real key is? How do we get ahead of the attackers? What do we do as defenders?
Ooh. So we're only as good as our weakest link. And I say that in the largest conception of we that you can imagine, right? That means that individual users have a responsibility to be cyber savvy. That means individual users have a responsibility to learn what a phishing attack looks like and to not, take the bait and get the hook in their mouth, right? Enterprises have a responsibility to manage their first party apps and APIs, as I described previously, with, built well and well defended security postures. they have a responsibility to manage their second party and to choose their second party technology and API well. That's, you know, folks like us, right, who are vendors to the world. You know, buyers need to scrutinize security practices of the enterprises they deal with, and that happens.
Yep.
Right? That's a given. Legacy apps, obsolete apps, rogue or zombie APIs are all critical to understand, to discover, to map, to manage, whether it's shutting them down or defending them well or virtually patching them. Because all it takes is one tiny vulnerability, one chink in the armor, if you will, you know, one crack in the wall for defenders to get a toehold. And then we're back to that living off the land, building a portfolio of exploitable vulnerabilities inside a network, and then they go to town. So,
Kevin Johnson of Secure Ideas said once, he said, you know, my job's easy, because he's a pen test company. My job's easy. I have to find that one hole. You have to find and plug them all. I just have to find the one you forgot.
Well,
but you
say that. Yeah. Sorry, Diana. We say that, you know, the attackers only have to be right once. You know,
so true.
Yeah.
You mentioned zombie APIs. What are those?
Yeah, sure. So remember before I said about, you know, how the world now talks about moving at the speed of DevOps, right? So here's a scenario. In January, a development team is working on product capabilities. Part of the product capabilities that they're building is a new website that'll allow you to order a pair of eyeglasses, right? So to do that, you're going to have a website that's going to let you put in your magnification for left and for right, and, you know, push that up to a website. Well, behind that website, there's an API endpoint, right? One of these little discrete functions of computational horsepower. And what that endpoint is doing is putting the left magnification and the right magnification in some database table, right? So great. So we released in January an API endpoint, and it's magnification commit, right? So it commits the magnification to the database. Time marches on. In April of that year, we shift models, and instead of letting the user put the numbers in, we say, all right, well, what we really want to see is a PDF of your report from your optometrist, right? So now we put a second version of that API out, and you know, different model. It's a completely different kind of transaction. It's putting a PDF out to disk, and because of the way that the code was deployed, that 1.0 API is still sitting there undeployed, right? Or still sitting there deployed. It's still potentially got a route path from the big I internet to that call. And your team has moved on, right? Because agile development is all about getting a story, putting it in progress, and then calling it done. And you never look back at what you did, right? It's always like forward. So this notion of a zombie API is that API that just committed 2 numbers to disk, was released. It was out there. And because maybe, you know, not great hygiene practices in that organization's CI/CD pipeline, or just because some container got stood up and it never got taken down because that's easy, it's still sitting there and it's still waiting for somebody to give it a number, which it'll write out to disk. Now, imagine a year goes by and some attacker finds that, and instead of writing a number to disk, they're like, why don't you write drop tables, you know, some SQL, some malicious SQL. And that gets executed, and because it wasn't well written or well defended and wasn't being watched by the OPSEC team because they didn't think it was deployed, that zombie API is now exploitable. So you know, it's sort of the dead APIs going around, you know, saying brains. So that's how we think about it.
And potentially leading a path for the attacker into your...
Exactly. Yeah.
So I was wondering, as we wrap up, thank you, first of all, so much for such a great conversation.
It's been great fun.
As we wrap, though, is there anything that you and your team are looking at specifically in the last 12 to 18 months that you think people should be aware of for security defense?
So some of the stuff that we're excited about, we're the biggest one is probably, you know, the way and the scale and the efficiency at which we aggregate indicators of risk on these mega entities, right?
Yeah.
That's under active development for us, and you know, there's a lot of interesting to us, but uninteresting details about how we'll pull that off with tagging at the perimeter, and you know, some fancy you know, data science work to pull all those together. The other one that's kind of relatively interesting to me is the notion of building kind of a performance envelope for existing web infrastructure to say, all right, you know, we know that 200 milliseconds is the average response time for this set of API calls, and then suddenly we see that go down, or sorry, down means slower. That could be an indication of either attack or malice or misconfiguration or bad code deployment. And that kind of automated discovery of transients in the operational environment is, I think, the next layer, because you know, it's easy if you're a good development shop to kind of build that into your tooling and your infrastructure and your monitoring. But if you know, you're running third-party APIs and a lot of legacy stuff, having that kind of built into your perimeter protection, to me seems pretty exciting stuff. So.
I completely agree. You know, we talk so much about you know, bringing down the threat landscape and really trying to control it. And this is another way that we can, by understanding the complexity we've created, that's another way to bring it down and manage it. Yeah. So, Tom, thank you so much. This has been just such a great conversation. And thank you, everybody who listened in and attended this ThreatX webinar on the evolving cyber threat landscape. We're really glad that you were able to join us, and we hope you'll join us on the next episode. Take care.
Absolutely. It was a pleasure. Thanks again.